Number 4. Now, we'll let Q equal to the vector 1, 1, 2. And again, we're just doing examples to get familiar with the notion of planes, to use the formulas, to use our intuition, geometric intuition regarding lines and planes and how they are. You're going to be doing actually a fair amount of that. So Q, and let P equal to 1, -1, and 3, and N equal to 2, 1, 3. Okay, now here we go. We want to find the point of intersection. Find the point of intersection of the line through P in the direction of N and the plane through Q perpendicular to N. Okay, so we have these 3 points, 3 vectors. We want to find the point of intersection of the line that passes through P and is moving in the direction of N, and the plane that passes through Q and is perpendicular to N. Okay, so this is often the case. You'll be given just some random points, and you have to draw it out. I mean, draw it out in 2 space or 3 space so that you can see what it is that's going on, so that you can decide what equations to use, what to set equal to what. So we have this plane, okay. Here's a plane, and I'll go ahead and put Q here. So this is Q. So, and then we have a line which passes through P. So here's some P, and it actually moves in the direction of N. So I'll go ahead and put N, yeah, it's fine. P, I'll go ahead and put N right on this. So N is like that. And this line that passes through P, it's in the direction of N. Okay. So this is the line P is in the direction of N, and this, we'll call this vector N. N could actually be anywhere, it doesn't really matter. I just happen to put it right on top of the line. And it's perpendicular to, passing through P in the direction of N, and the plane through Q and perpendicular to N. So what we're looking for is basically this point right here, this point of intersection, this X. Where does the line actually cross that axis? Okay, so let's see what we've got here. Let's go ahead and find some equations here. So we know that let X equal the point P plus T times the vector N. So that's the equation of the line that passes through P that is in the direction of N. Okay. And actually, let me specify these a little bit better. So we say that the line is equal to X is equal to P plus T times N. And now we'll do an equation for the plane. The plane is going to be X minus Q. Okay, so we want to have, remember we said this vector. So the equation of the plane is X minus Q. I think I'll use a small q here. So X minus Q dot N is equal to 0. That's the equation of the plane that passes through Q and is perpendicular to N. And this is the equation of the line that passes through P is in the direction of N. We want the point of intersection. In other words, we want the value X that makes this true. Well, the value X that makes this true, just take this X and put it in here. That's all you got to do. So we'll take this x, which is p plus tn, p plus t times n, and I'm sorry if I keep going back and forth between upper and lower cases. Let me be consistent. N, that's x, minus q dot n is equal to 0. So we took the equation of the line and the equation of the plane. We want the point of intersection. Well, the point of intersection is a point that is actually on both, that satisfies both. So I took the value x and I just stuck it in for this value x here. A simple substitution. And now I solve this. So let me see what I do. So let me go ahead and distribute the dot product here. So this becomes p dot n, excuse me, plus t times n dot n, I can do that, minus q dot n is equal to 0. Okay, and now we just do it. When I take p dot n, I end up with 10. When I take, this is going to be t, when I take n dot n, I end up with 14. And when I end up doing q dot n, I end up with minus 9 equals 0. So I end up with 14t is equal to negative 1. Let me write this a little clearer, getting some of these wacky lines again down at the bottom of the page. 14t equals negative 1. Therefore, t is equal to minus 1 over 14. So the value of t that makes this true, that gives us this point x, is negative 1 over 14. Now, of course, I have to take this and put it back into here and solve this equation for the actual point x. So let's go ahead and do that. So x, again, let me rewrite the equation, is p plus t times n. This is equal to 1 minus 1, 3, and notice this time I'm writing them vertically, plus t, which we said was negative 1/14, times n, which is 213. That equals 1 minus 1 and 3 minus 2/14. Let me see, minus 2/14, minus minus, this is 1/14. Actually, you know what? I think I'm going to go ahead and leave the plus sign there. I actually don't like, yeah, so I'm going to go ahead and leave this plus sign as is. And I'll just multiply the negative 1/14 times 2, which is negative 2/14. Negative 1 times the 1, which is, wait, where am I? Yes, negative 1 times 1, which is negative 1/14, and negative 1/14 times 3 is negative 3/14. So you can do it either way if you want. If you want to pull this negative out, that's fine. So there you go. This is our answer. And you can do the addition if you want. This plus that, this plus that, this plus that. It's going to give you some vector. This value, this value, this value. This value is the sum of those two. This value is the sum of those two in the middle. And this is the sum of those two. And that's it. So again, we started off with just a standard definition of a plane that passes through a given point that is perpendicular to some vector. And then, of course, we had what we had previously, the equation of a line in any dimensional space is a point P plus some parameter t. T is just some real number in the direction of n. So take a point, and the vector is in this direction. It's going to be this direction and that direction. It's a line. So we're just using our geometric intuition, what it is that we know about geometry, what it is we know about perpendicularity, to get comfortable with these sort of straight algebraic definitions in vector form. Okay, thank you for joining us here at Educator.com, and we'll see you next time for a continued discussion of planes. Take care. Bye-bye.